15th question. The time period of a body suspended from a spring is capital T. What will be the new time period if the spring is cut into two equal parts and the mass is suspended one from one part, then second is simultaneously from both the parts. Okay, so there is a one spring here like this. Okay, this is our spring. Okay, so then this spring is having some spring constant k, and its time period is given, that is equal to capital T. Okay, so then a body is suspended here, and this is the body is suspended here, and while after suspending this body the time period is capital T. Then what will be the new time period if the spring is cut into two equal parts and the mass is suspended from one part? Okay, so this we are divided into two parts. Okay, this is another one part up to here, and from this it is another part. Okay, so then it is having another k value, and it is also having another k value. Okay, because we are cut into two equal parts. Okay, means every part is having same because we are equally divided this spring. Okay, then what is the time period after after cut into two pieces and hanging by one part? Okay, so then another is if two parts. Okay, then we have to take the first one. Okay, so the time period T is equal to 2 pi under the root of m by k. Okay, so this is time period of a spring and block system. Okay, so first we are taking here first question, that is, what is the first question? That is equal to, so spring is cut into two parts. Okay, spring cut into two equal parts. Okay, then we are taking one part only like this. Okay, this is one part. Okay, and for that one part we are hanging the mass. Okay, here after cutting these two this total spring into two equal parts, and its k value is k prime. Okay, before cutting it is having k, and after cutting it is equal to k prime. Then what is the k prime here? Okay, so for suppose here we know that Hooke's law, f is equal to minus kx. Forget about minus, we are taking here magnitude. Okay, so then magnitude of the spring force is f is equal to kx. If we are cutting this spring, okay, then this x is nothing but here elongation. Okay, means here length of the spring. So if length of the spring is cut into two pieces, that is x by 2, then when x is equal to half, means length of the spring is decreased half, we are cut into two pieces, then the affected spring constant we are taken as k prime. Okay, then f is equal to f. Okay, so then from this what is this, if you are taking to this side, that is 2f is equal to k prime into x. Okay, so if you are taking to this side, then that is 2f is equal to k prime into x. Then we know that f is equal to how much? F is equal to kx from this. Okay, and that is equal to how we can write it is k prime into x. Okay, 1x cancel, and that is k prime is equal to how much? 2 into k. Okay, this is the when a spring of spring constant k is cut into two equal parts, then the affected, means the one part of the spring constant k prime is equal to how much? 2k. So that's why it is also how much? this is k prime, that is equal to 2k. Then what is the time period of this new um, spring and block system? That is equal to how much? So k prime is equal to 2k. Okay, then time period t is equal to under the root, 2 pi under the root of m by k. In place of k prime, here it is equal to k prime, and that is t is equal to 2 pi under the root of m by k prime. K prime is equal to how much? 2k. Okay, so this is the first question. And second question is what? Here here we are taking only one part of the uh, this spring, and for that we are hanging the mass, and here in this we are taking the two parts like this. Okay, this is one part and this is another part. Okay, it is also having k dash and it is also having k dash, and for these two we are hanging the mass m after cutting to two pieces, and for the two pieces we are hanging the weight. Then it is having 2k and it is also having 2k. Then in this case, what is the time period? So time period t is equal to so that is time period t is equal to 2 pi under the root of m by k. What is the k here? This k and this k, that is equal to k prime plus k prime, and that is equal to 2 pi under the root of m by 2k prime. Okay, so 2k prime means, and this is equal to 2 pi under the root of m by 2k prime means 2 into k prime. K prime is equal to 2k. Okay, so which is equal to, this is 2 pi under the root of m by k I am keeping here 2 into 2 4, and that 4 I am writing by 2 here. Okay, so after taking from the root, that is 1 by 4 and 1 by 4 in the root, and if you are taking outside it is equal to uh, 1 by 2. So that is equal to 1 by 2 of, it is nothing but here, this is 2 pi under the root of m by k, and this is equal to how much? 1 by 2. This is totally is equal to t, so that is equal to t. Okay, this is the new time period. Okay, and here is also we can write it is like this. Okay, so this is 2 pi m by 2k. So means here from this equation I am taking 1 by root 2 is I'm writing separately. Okay, and the remaining is here, this is 2 pi and under the root of m by k. Okay, so from this here 1 by root 2 we are writing out here in front of this. Okay, then it is equal to 1 by root 2 of this, total is equal to what? That is equal to t. So this is t by root 2 when we are hanging mass for one part of the spring, then the time period is equal to like this. Okay, so this is t dash is equal to t by root 2, and when we are hanging for two springs, then that is equal to t double prime is equal to t by 2.